So today we're talking about heating water. And the big question we're trying to solve eventually is what solution can we dream to solve problems with heat in our world? And the goal for today is for you by the end to be able to say, I can describe the effect of heat on water. Our vocabulary for today, we have thermal energy, which means heat that transfers from a place of higher temperature to a place of lower temperature. Expand, which just means to spread out. Matter spreads out, takes up more space. Particle, which is the smaller parts of something that make up the bigger thing. So the smaller parts. To melt is when heat causes particles to go from a solid, so stuck tightly packed together, to a liquid. And then evaporate is when heat causes the particles to move more quickly and you go from a liquid to a gas. Evaporate is going from a liquid to a gas. Okay, but let's talk about first what happens with heat. Heat means expanding. So when heating matter, it causes the particles to expand, which we know means to spread out, right? We see this as melting or evaporating. Heat causes things to expand or spread out. Heating also causes things to evaporate, like we just said. Evaporation is when the particles go from being a liquid to a gas. So they get enough energy so that they can spread out, and they spread out and they have so much energy that they become light and they start to rise. So think about steam when you're boiling something, when you're boiling a liquid like water. When you have water boiling in a pot, you have steam rising above it, or even think about clouds. Clouds are actually combined or made from water that has evaporated. Okay? Heating also means to melt, like we said, and that's when you go from a solid to a liquid, right? But we can't see those particles, each individual little particle spreading out. We see them all moving at the same time, and we know that as melting. So maybe we have a liquid that's been heated so much, like this molten metal that's heated and becomes soft and melted out of this container. Or even we have water that has melted, like the ice cube that started to melt and spread out. Now, there is one exception to this rule, okay? And that is water. Water is in its own class. Water is the only exception. Water actually takes up less space when it melts. When you heat water, it starts to come back together, but it becomes a liquid again. When you freeze it, it takes up more space. So we're going to think about potholes. Potholes are a great example. I know you've been driving in the car before or riding in the car, maybe on the bus, and you've seen these big gaps in the road with water in them. Well, what happens is there are little bitty cracks in the asphalt in the road, and the water, when it rains, gets down in those cracks. And what happens is when it gets cold enough, that water that got down in those little bitty cracks freezes. And when water freezes, it expands, it spreads out when water freezes. So it pushes. It pushes the asphalt, it pushes the road, and makes that crack bigger and bigger and bigger until it's what's left is this big gaping hole. And when that water melts, it goes back down, comes back together, but the hole is left behind. Okay, that's how these big potholes are formed. They're formed because water actually takes up less space when it melts, but when it freezes, it spreads out and pushes everything out of its way. All right, now go ahead and do your exit ticket so I know that you have watched and understood this video. Talk to you soon. Bye bye.